Hey guys, welcome back. Today we are going to talk about factoring. It should be a review, but it's going to help us do the other things in Unit 7 that deal with all the polynomials. So today we're going to focus on how do I factor a polynomial expression. Okay, and so we're going to start with that graphic organizer that I passed out, and this is going to kind of lead you through the steps of how you factor a polynomial. The first thing that you always have to check for is a GCF when you are factoring. So that's a greatest common factor. For instance, if both your terms have an x in them, you factor out an x. If they're both even, you can factor out a 2. But that's going to help us when we get to the next box, which says, how many terms does the polynomial have? Okay, so we have 3 different options here, 3, 2, or 4. So the first method is when you have 3 terms, when you have a trinomial. And there are lots of different things that you may have learned in Algebra 1 or Algebra 2. This is where you get to pick what you're comfortable with. So you may have factored using the AC method, which is kind of when you use that x and you put a times c up in the top and b down in the bottom, and you ask yourself what factors into, or what factors multiply to a times c and add it to bb. You also might have used the box. And some of us learned guess and check. Okay, and again, trinomials, those are the rough ones. They're really hard when you have a term that's not 1 in front of x squared. But we'll walk through how we would do that in a little bit. But if you see a trinomial, you're going to try one of these 3 methods in order to factor it into 2 things that multiply to get you to the answer. Okay, the other one that you might see is 4 terms. And that's where we're going to just use grouping, or perhaps the box. Okay, basically 3 and 4 terms are the same idea. The only problem with 3 terms is you have to split that middle term into that 4th term, so then you can use this method. So 3 and 4 terms are actually pretty similar. It's just you have to do one step in the beginning with a trinomial. Okay, the other thing you might want to look for is if you only have 2 terms, then you're going to ask yourself, are those terms perfect squares or perfect cubes? And so squares are obviously going to be anything to an even power. Okay, you also know 1 squared is 1, 2 squared is 2, 3, 4, whoa, can't do that, 3 squared is 9, etc., etc. Okay, so you recognize those squares, and we know that if it's a difference of squares, a squared minus b squared is going to factor into a plus b and a minus b. So difference of squares we like a lot. It's pretty straightforward to factor. Cubes get a little bit more tricky, and that's when you see things like 1, 8, 27, I almost said 16, 8, 64, all of those are perfect cubes. Okay, and you probably want to know up until 5 cubes. So we would have 1 is 1 cubed, 8 is 2 cubed, 27 is 3 cubed, 64 is 4 cubed, and 125 is 5 cubed. So if you recognize that you have some cubes, there are some formulas that you can use for the difference of cubes and the sum of cubes. So if you had a cubed minus b cubed, that would factor into a minus b times a squared plus ab plus b squared. Okay, and I'll show you how you can memorize this in a second. So that would be a difference of cubes. Now if you had a sum of cubes, we actually can factor that. We can't factor a sum of squares, but we can factor a sum of cubes. And it's going to look really similar. You're just going to notice that the signs change. So a plus b times a squared minus ab plus b squared. So basically what's happening in here is you're only going to use the a and the b. So in order to factor this, you're going to have to take the cube root of the first term and the cube root of the second one, and then plug it into your formula. Now I remember what the signs look like on this for the word soap. Okay, so when you look at the sign here, this is a minus sign. So the first sign is going to be the same. So you have same sign for the first one. Okay, then the second sign you see is going to be the opposite sign. So since this was a minus, now it's a plus. And then finally, that last term is always positive. So it works the same way for the sum. You have the same sign in your first factor, you have the opposite sign in the second part, and then the third sign is always going to be positive. And again, you're just going to take the cube root of the first term and plug it in wherever you have an A, and then you're going to take the cube root of the second term and plug it in wherever you have a B. Okay, so that's kind of a helpful flow chart for you to figure out how to factor stuff. So let's use that flow chart in order to do some examples. Okay, so we're going to start pretty straightforward, except for this definitely should say 64. Okay, sorry about that. I was like, that is not a perfect square. So we have 49 minus 64x squared. And right away you recognize 49 is 7 squared and 64 is 8 squared. So in order to figure out what a and b are, I can just take the square root. So the first one, a, would be the square root of 49, which would get me 7. And then b is going to be the square root of 64, and then don't forget the x squared. We know the square root of a square is just going to be that number, and then the square root of 64 is 8. So all I have to do now is plug that in. So my difference of squares is going to be a minus b times a plus b. And so right here, all I got to do is plug that in. So I would have that my a was 7 and my b was 8. So this is my factor form. Okay, so pretty straightforward. I just totally crossed out some of my answer. That's okay. And so that's just what two things multiply to give me that beginning term. Okay, so squares are pretty straightforward. You've done that a lot. Always find the square root of the second, or sorry, the first, and then the square root of the second. Okay, now it's the cubes that get a little bit more tricky. So the first thing is I notice that we have a cube on my variable. That's kind of a tip off for me that I need to do something with that. So I think about 8. 8 is 2 cubed, and 125 is 5 cubed. So again, if you go back to that chart, remember some of those special cubes. Here, I'll go back and look. These are the ones that show up most often. Okay, but you may see other ones as well. So we're going to go ahead and know those two things. So if I know that a cubed is 8x squared, or x cubed, sorry, a must be 2 times x. Okay, and then b must be the cube root of 125 is just 5. Okay, and then I can plug it into that formula. So if you look on that chart, it tells you the difference of cubes, or sorry, the sum of cubes. I'm struggling with words today. The sum of cubes, we're going to have that one formula, or you can just remember SOAP. So I'm going to plug in my a and my b wherever I have it. So we know that since it's a positive, my first thing is going to be a plus b. They have the same sign. Okay, my second parentheses is going to have my a term squared. So if you had a squared, you would have 2x squared. Please, please, please remember that you have to square every single piece. So that's 2 squared and x squared. So my second term, or my first term in here, should be 4x squared. That's a squared. Okay, now you're going to have the opposite sign in between for the second sign, and you're going to times a times b. So that would get me 10x. And then finally, you're going to take b squared, which is just 5 times 5, which is 25, and that last sign is always positive. Okay, and so that is that factored out. And again, you can memorize that formula, or you can just think about that sign thing that changes. And then all you have to remember is a squared minus ab plus b squared. Okay, now, if you look at number 3, we automatically would assume this was a difference of cubes because I see an x cubed in it. But 2 doesn't have that, it doesn't have a perfect cube, and 54 isn't either. But if I look at these, both of them are even. And so that automatically tells me I need to always look for that GCF first. Okay, so if I take out that GCF, which is 2, if I divide 54 by 2, that's 27. Divide that by 2, that's just x cubed. And now I have perfect cubes. Okay, so they're going to try to trick you like that. Make sure you always find the GCF before you start, whether it's a variable or a number. Okay, and so now I look, and this is now a difference of cubes on the inside. Remember, your answer is going to have a 2 in it. So I always just kind of write my thing over here just to make sure I have it. And then I'm going to think about all of those pieces. So for the inside here, we have 27, which is 3 cubed, which would make a equal to 3. And then my b is just x. And since it's a minus sign, we're going to have a minus, same sign, x, Then I'm going to square a, which is 9, then times x times 3, which is just 3x, and then you're going to have the opposite sign, so plus. And then finally, we just add that last term, which is x squared. Okay, so that one was pretty simple. We just had to make sure that we first found the GCF and didn't automatically assume it was prime just because it didn't look like it factored right away. Okay, so last but not least, we have our favorite term, our favorite type of grouping or factoring, I guess, which is the trinomial that has an a that's not 1. Okay, so when I look in here, I'm going through, I can't find a GCF. And so I think, okay, well, since I have 3 terms, what I've got to do is split the middle term. And that's what the purpose of this x is. And something that helps me remember what goes in the x is that your air conditioning is in the ceiling. So you're going to take your a times your c, and this is a, and this is c. So I'm going to take 6 times negative 15, which gets me negative 90. And then at the bottom of your x, you have the basement. Okay, so your air conditioning is in the ceiling, your basement's at the bottom, and so my x right here, or my b, that's the numbers next to the x, is just a 1. So I'm looking for those factors of negative 90 that add up to be a positive 1. And I tend to write the sign in there just because sometimes I get tripped up. And then if you think about it, you would want, since this number is positive, you want your bigger number to be positive. So if I have 10 and negative 9, that's how I'm going to split the middle term. If you can't figure out what those factors are, there's a nifty trick in your calculator you can do. And if you go ahead and you type into y equals your a times c, which you could just find on your home screen, divided by x, and then you go to the table, so you go to second graph, and you can just look through the table to find all the factors. Obviously, you don't want ones that are decimals, and 0 is always going to give you an error. So if I look right here, if I add those two up, that gives me positive 1. Okay, back to this. So the whole purpose of this x is to split that middle term. So what we're not actually changing the value of your expression, we're just making it so I can actually do something with it. So we would have, I didn't do anything with the first term. I split that second term into 10, and I'm going to put an x next to it, and minus 9. And then I left that c term alone. So if you look here, nothing has actually changed. This still adds up to be the same expression that it was, it's just now it's a little bit longer. And this is the point where we group. So what we're going to do here is we're going to take the first 2 terms and group them together, and take the second 2 terms and group them together, and then just look for the GCF. So I know in both of these first 2 terms, they both can divide by 2, and they can both divide by an x. So I take out a 2x, and then I write whatever's left over. So I'd have 3x, and then 5. For the second part, just keep this sign from this one, and it should always work out. So I'm going to take out a minus, and then both of these guys divide by 3. And what I'm left with is 3x. And be careful here, because you took out a negative right here. That means that this guy would have to actually be a positive. The other thing that you can always check is you look and see, are these 2 factors the same? Because if they're not the same, then you've messed up somewhere, or it doesn't factor right. So that factor that shows up twice is actually one of your factors, so 3x plus 5. Okay, and then your other factor is whatever is left over, so 2x, the stuff outside the parentheses. Okay, and if you did this with a box, it's the same idea. It's just now you're putting it into the little boxes instead of in with parentheses. Okay, so that is the idea behind trinomial factoring. You're just splitting up that middle term and then grouping stuff together so then you can figure out what times what gives you that answer. And again, you can always check your work by multiplying it out. Last but not least, we have this guy, which is a 4 term, which is actually pretty straightforward compared to this guy. So first of all, the only thing you really have to worry about is making sure that you reorder in case of anything. So you always make sure your biggest term, so your highest exponent is first, and then it goes down the line. And then we're going to go ahead and do the same thing that I just did. So I'm going to group the first 2 and group the second 2. Well, I guess the last 2. Then you just find your GCF between them. So you have x to the 5 and x to the 3, which means the highest power of x that you can take out is x to the 3. You think about what's left over, you would have x, I took out 3 x's, so I get 2 x's left, and then just a 4. Okay, remember, keep this sign right here. Keep this sign in front of your second set because that's going to help you out a little bit. And if you notice, nothing is going to go into those two. They have a common factor of just 1. So I'm going to make sure I write my 1 outside the parentheses so I don't lose it. And then I think about what times -1 gave me negative x squared, x squared. And then what times -1 gave me +4, well, that'd have to be -4. Okay, I check my factors match in here. That's awesome. So that means this one's done. And then I have x cubed minus 1 left over. So that's 4-term grouping. Now, I'm really excited that you got this far because, cool, great, that looks pretty factored to me. However, if you look at that first one, this is going to be a difference of squares. We have x squared minus 4. So I have to factor this completely. So that would mean that that would have x minus 2 times x plus 2. That's what that first one factors into. And then I look at my second one, and I'm like, oh cool, there's a cube, and 1 is 1 cube. So this is actually a difference of cubes, where a is just x and b is 1. So then I have to factor that piece. So I'd have x minus 1. Again, this is just a difference of cubes. Use that formula. Then we'd have x squared plus x, and then always positive 1 squared. So again, if you got to this piece, I would be super proud, but it would not be factored completely. This is considered factored completely. Alrighty, I hope that was a great review for you of how to factor polynomials, all different types. I will see you tomorrow.